Hey guys, so I plan to do a sort of video. I don't know if I'm actually gonna go through with it, but to try to more or less do some tests and to study a little bit of how the garbage collector of the .NET runtime works. But to actually test the .NET runtime, garbage collector, one thing that was very useful to me is taking some, being able to generate the information about how my heap, what information was in the heap of my program during the runtime. And that is what I'm going to teach you how to do. So there is a very simple way to do this. It works on both Linux and Windows, which is to use a tool called Dotnet Dump. So the first thing we're going to actually do is install Dotnet Dump. To do Dotnet to install global Dotnet Dump. You should have .NET, so that's hopefully not a step you're going to be confused on. Once we have .NET Dump, we can start taking screenshots of basically any application we run. So the test I'm going to run is this program, which you can see that I'm on the folder of, called compactation in the large object heap. So if I do want to view the program, I can sort of show it to you. And this program is basically testing the garbage collector. Specifically, I wanted to test the garbage collector on the large object heap. So if you don't know anything about the garbage collector in C#, the garbage collector, when doing things, when doing memory allocation and memory release, it will organize the heap of a program in sort of two main areas, which is the small object heap and the large object heap. And basically the threshold that it uses for an object to enter either of these heaps, from what I remember from memory, is 85,000 bytes. And the reason it does that is basically because the small object heap is in general very compacted. By compacted, I mean that the objects are always very close to each other in memory. Any like holes that are left like in the registers, not in the registers, of course, in your memory, are not just left there. Like objects are copied and moved around to occupy those holes. So when the program actually wants to like run through the objects, it can do that very quickly. On the large object heap, this doesn't happen. And the reason why it doesn't happen is that if you study, your lower level languages like C or copying a large object, either a large structure or a large array, from like a certain point in memory to another, can be quite expensive. It can take a lot of time. So the runtime just kind of judges that doing those sort of compactations for large object is not worth it. That's why there is a separation from the large object heap from the small object heap. There are some other differences, like the garbage collector. The heap also has like what we call generations, which are kind of states that the garbage collector classify your managed data according to how much it thinks it will stay on the program, so it can collect the data that it thinks it already live longer, less frequently. And in general, the large object heaps are always collected like what we call generation 2. So this means they are not collected as frequently as like more volatile objects. So anyway, that's kind of the nerdy purpose of this program, but I'm just going to kind of show the garbage collector actually garbage collecting through doing screenshots of the heap. So let's see what is that. We have like a class here, and it stores some reference to some integers. And we immediately initialize it here, and we use this function. The reason I'm using this function is because I want to actually create the integers on a function with a separate stack to guarantee the garbage collector does not really think it's important to keep those things in memory. So the garbage collector, usually what it does is that it collects, it will choose what you call a root of the program, which is sort of the memory in the stack, the memory of static objects and other things, and then it would like try to see all the objects connected to them through references, and we'll free everything else. So if we declare those in this stack, which is the stack of another function, and then dereference them later. I mean, they're not on the stack at all, so this probably makes no difference actually. But my point is, I mean, we would have a reference here maybe. But anyway, if we like declare them here, then we lose the reference to them, as I'm doing here. When you call garbage collector, it should clear those variables up. So that's what I'm doing. My program has this console write line, the read line, which started to wait for input. And yeah, we're gonna just run this program, and we're going to test this operation of the garbage collector. Oops. Okay, so our program is running right now, and it's on the for garbage collector input, for garbage collection input, and it's right now that we're going to actually use the Dotnet Dump to analyze how the heap memory looks right now. So let's go to another window. So the first thing we will need to do is that we will need to identify what is the process ID of our program. And to do that, we can do it through Dotnet Dump itself. Dotnet Dump has a function called PS, which it will show the ID of all currently .NET processes running within your system. So I have a VCBS compiler, which I'm really confused, to be honest. Oh, it's Roslyn. It's my language server. I'm not sure why it's active. I generally leave it off by default, but okay. And we have our program here, and we have the .NET runtime itself running. And we can see that the code of our program is 15.26.5. So now that we know this PID here, we can do .NET dump collect, which is to actually generate a dump. And it will generate a file, okay, in this folder, so be aware of that. You don't let things get a bit disorganized. We do P to insert the process ID, and we do 15, 26, and 5. And then you can do the type, and the type is going to choose whether it's going to generate all the memory information of the program, including some more like metadata stuff, which I'm not too interesting, or just generate the actual shot of the heap, which I'll do that. And for the last, I'm actually going to name this file because we're going to generate 2 memory dumps. We're going to generate one before that garbage collector that I said, and one after it. So we're going to call this before collection. And it does this pretty quick. So a kind of naive thing you might want to do is just neo-vin into it, and that won't be good. That's not good. It doesn't generate just an easy text document for you to see. It actually generates a specific file type, which you can only see information through an interface in Dotnet Dump. So if you do Dotnet Dump, then analyze, and put it the file name, we enter it. We are in an interface to analyze this file, and basically the command we're going to really use in this video is dump head. And once, dump heap. We're gonna use dump heap. So here, it's going to actually have an idea of what it wants to do, because metadata can make things pretty crammed. And in this case, let's actually go back to our code a little bit. I actually know pretty well what I want to take a look at, which are in those integers. So system.int32, and that's the only thing, so I'm quite lucky. And you can see that it's occupying 4 megabytes. That's 4 megabytes because it's measuring in bytes. So it's like 1,000. That's 1,000, so it's a mega. So yeah, that's a lot of integers, but that's what you expected because those are large arrays. Look at that. So now to show you that how interactive this is, I mean it's not interactive enough that I can do it on the same file. But what I will show is that I can take another dump of the memory. So let's go back here, where we executed the program. You can see that after we did the before garbage collector, it's not actually after, it's during the input. it actually says right here that we created a dump for this program. So that's pretty useful. Now we do enter. And what happened? Well, I went from this point in the program to this point in the program. And the thing that happened is that I call gc.collect. Now, should gc.collect have done something? Yes, it should. Because I lost the reference to those arrays that I created in the heaps here. And when the GC collectors see that the roots of your program don't have anymore any sort of reference to that in the sort of program graph, they will like just clean up that memory. And let's visualize this. Let's go and do a node. I'm gonna exit this interface. Well, I'm gonna exit this, but I will actually not mess with that terminal because I want to keep this number easy to see that. So let's go here to another terminal. Let's do .NET Dump collect p 15.26.5 type heap. Oh, I should have wrote the. Well, I didn't. I should have wrote a. I should have outputted it into something with a file name. I'll do that, but it's alright. .NET Dump analyze this mess we just created, and you're gonna call dump heap again. And look at that, it's now weighs 2 megabytes instead of the 4 megabytes. So it's approximately, I think it's actually, yeah, it's half of what was there. And that's very cool. What just happened is that, you know, there are 4 of those arrays. We lose reference to 2, so the garbage collector cleared 2 of them. So the garbage collector did exactly what we thought it would. So that's this video. I'm just showing this tool. There are probably more things you can get deep into it, but I hope this helps at least get into some starting into, you know, analyzing the heap of your program dynamically. Bye.